This is the Chapter 7 review for Geometry 1C. So the first 6 problems are proportions solved by cross product. So for number 1, you want to multiply diagonally. So from b times 8, set that equal to 3 times 5. Get your calculator out if you need to. And then reduce if you can. This one you cannot reduce. Number 2, same thing. You want to multiply cross product. So you're going to do 3 times n, set that equal to 7 times 2. You should get 14, then divide both sides by 3. Number 3, this one involves distributing. So I did 7 times the x minus 4 and then distributed to each of those. And then 5 times 3 is 15. After you distribute, you want to add 28 to both sides and then divide both sides by 7. So you should get 43 over 7. Number 4, I multiplied the v minus 1 times 2. I distributed backwards. And then 7 times 10 is 70. Add 2 to both sides. Divide both sides by 2. You should get v equals 36. Number 5, we've got 6 times n minus 8. Set it equal to 4 times the n minus 2. So you have to distribute on both sides of the equal sign. Getting you to 6n minus 48 equal to 4n minus 8. I did 2 steps at once. I subtracted 4n from both sides. And I added 48 to both sides, which got me to 2n equals 40. Divide both sides by 2. You should end up with n equals 20. Number 6, same thing. You're going to distribute on both sides of the equal sign. I did both steps at the same time. Subtracted the 16, subtracted the 8, which got me negative 4a equals 0. 0 divided by any number is just still 0. The next 4 questions, they're telling you that the polygons are similar, so they want you to solve for x. The easiest way to do it is to set up a proportion. So for the number 7, I use the figure on the left, or the left side of my proportion, and I use the figure on the right. For the right side of my proportion, just did top to bottom, so numerator to denominator, and then I did the cross product. So I'm going to need to distribute when I go this way, and then this way, just punch it in my calculator, subtract 30 from both sides, divide both sides by 10, so x is equal to 9. Number 8, again, 2 similar polygons. They gave you a piece of extra information that you don't need, so I crossed it off, and I used these 2 numbers for the left side of my proportion, and these 2 expressions for the right side of my proportion. Then I did distributive with my cross product. Isolated that variable by doing inverse operations till I got x equals 7. Number 9, I used, they give you way more information than you need. Like you don't need the 20 and the 15, and you don't need this 12.3. So I just used the top and the bottom because they're both facing the same direction. I kept this one on the left and this one on the right. So I did 12 to 32, set that equal to 9 over 3x minus 3, used the distributive over here, and then did inverse operations till I got my variable by itself. Number 10, I just drew an imaginary line which made a left side, numerator, denominator, right side, numerator, denominator. When I did my cross product, I have to distribute on the left. Then I did inverse operations, so add 340 to both sides, divide both sides by 40, you'll get x equals 12. Turn over to page 2. Page 2, the directions say, state if the triangles are similar in each pair. If so, state how you know they are similar and complete the similarity statement. So number 11, I just checked my sides to see if they're proportional, because I know these 2 angles right here are going to be congruent, but I need to check the side. So I did 26 to 36, but because this one's turned, I had to put this in the numerator and this in the denominator, did the cross product, and I didn't get the same number, so they're not going to be similar. Number 12, I noticed right away that this angle is 94 and this angle is 98, so they're definitely not similar because they would need to be congruent. Number 13, I have a triangle inside of a triangle, so I know they're sharing this angle right here. Okay, so I checked to see if the sides were proportional. So I kind of drew an imaginary line down the middle did the numerator to denominator, did the cross product, and got them equal. So this one is similar by side, angle, side, similarity. All right, number 14. This one is turned, so when I did my ratios of my sides, I did 8 to 15, and I can tell because they're the smallest numbers on each of the triangles. Punched in my calculator, I got 0.53. Then I did the next largest numbers, which were the 18 and the 30, got 0.6. So I'm pretty sure right there that, yeah, they're not similar. But I did the third one just for good measure and said, okay, no, these two triangles are not similar. All right, number 15. I knew these two angles were congruent because they're vertical angles, so I gave them each double arcs. These are obviously congruent because they both have the same measure, which means that these two triangles are similar by angle-angle similarity, which technically makes their third angles similar. So the similar triangle is triangle JVW. And the way I figured it out is I just put the number for each of these. J, I put 1, K, I put 2, L, I put 3, and then I knew I had to go 1, 2, 3 for that one, so JVW. All right, and number 16. This one was a little bit trickier, but I did notice these little marks right here and right here. These are called carets. They mean that these two lines are parallel. So whenever you have parallel lines, you should look for the transversal, which is right here. And then I saw a pair of alternate interior angles, and they're congruent. So I got this angle and this angle congruent. And then these two are congruent because they're vertical. So I said that yes, they are similar by angle-angle similarity. And then I just numbered again, 1, 2, 3. So I knew this one was turned, so it's got to go 1, 2, 3. And that's how they're similar.